So we're going to continue with 8.05, the positional difference. It's on page 180, as you can see here in your book. So first of all, then we'll talk about positional difference or voltage. What does that mean? So as we take the last example for the cell, if we have here a cell, so the cell, we said that it gives power, right? So the power, or the electrons, it's the power, are going out from the cell and going to the lamp, including this thin filament, and it keeps going to the positive part from the cell. So that's when the electrons coming to this lamp, it will glow. Okay? When it's glowing, that means what? There is a power in it. So what happened to the cell actually when the lamp is turned on? That there will be current. So for example, this cell is 1.05 volt. What happens when the electrons start here, the potential power the electrons will be wasted here. Okay? So the volt will be less than 1.05 volt here. Okay? So the thing is, more current, that means less voltage or less potential difference. As you can see, the scientific name for the voltage is the potential difference. So what does that mean? That means in every 1 volt we have, it's 1 joule per coulomb. Per coulomb, that's for charge, we talked about that already. So more current here, that means less volt. Why? As you see here, the power is wasted with the electrons. For example, a car, the car battery, it's about 60 ampere normal cars and 12 volt. Let's focus on the volt. So the car usually is 12 volt, okay? So if it's 12 volt, but when the car is not moving. So when we turn on the car and we start the car, the volt will go down to 9 volt, from the 12 to 9. Why is that? As you say, when there will be more current, that means the volt will go down. Why? Again, because the wasted electrons on the load. Okay? Now we move apart to cells in series. So how are we gonna do if I have just a cell? It's 1.05 volt, but I need 12 volt, for example, or 6 volt even. So it is actually the battery. It means it's a joint of connected cells. Okay, so every cell is 1.05 volt. That means in conclusion, the battery is 6 volt. Okay, so more cells, that means more volt in the battery. Let's see, 1.05, 4 times is 6. Of course, for the symbol, you found it like this. That means this one cell and this other cell, and there is the cells between. Continue mobility around the circuit. So we take ammeter for measuring the current. But now how I'm gonna measure the volt? For the potential difference here around the circuit, for example, we have here 2 cells, let's say 1.5 volt. If I bring a voltmeter and put it here, it will give me 3 volt. Okay, let's focus here. Now, let me bring another color so you know the difference. So, if I have here small lamp, and I have here big lamp, I have here the source or the cells or the battery, whatever, it's 3 volt. Okay? So the thing is, the current coming up from here, taking up the filament, what we say here, the volt will go down. Continue, again the volt will go down, coming back to the battery or to the cell. So we find here that if we check a volt ammeter, first of all, a volt ammeter, it's not connected like the ammeter. The volt measurement, it's not connected as the ammeter. So if we have here a normal cell, okay, with the lamp, as we say, or let me put the normal symbol for the lamp. I can put here ammeter and connect it, and I know the current for the circuit. But in the voltage, no, it's not like this. For the voltage, it is, let's draw another one. I have here lamp, and here the source. I have to put the two sides for the voltmeter. I have to put them on the sides of the load. And if I want to know the cell, I have to put them in the sides here. Here should be the voltmeter, and here should be the voltmeter. Okay? So we know the potential difference. Of course, as the ammeter, it don't take energy, so it's like connecting wire. So here, how I'm gonna know that? We put here a voltmeter. So it's gonna give me 3 volt. Why? Because it's 2 cells, 1.5, or a battery, or whatever. So now what's happened? Let's focus here. A small lamp, it takes 1 volt. What? Joule per coulomb. That's mean it takes power from the charge. That's mean here, if I bring a voltmeter here, it'll give me the reading of 1 volt. Okay? Not 3, 1. Because this is the what? The power wasted, because there is more current. But here the big lamp will give me a reading of, here is 2 volt. So it'll give me a reading for 2 volt. Why? Because it's bigger lamp, that's more power wasted. Okay? So in conclusion, 1 volt and 2 volt will give us the 3 volt, like as much as the battery. So almost there's no power extra, just like the connecting wire take nothing, like you can't finish it. So for this, let me say 1 volt, 2 volt. Why? Because this is smaller and this is bigger. Small lamp and big lamp. So how are we gonna draw this in symbols? As we can see here, here's the cell. Here the 3 volt. Here's the first small lamp, and this is the big lamp. So this, if we put the voltage meter here, it will be 1 volt, and if we put voltage meter here, it will be 2 volts.